the May-June 2025 Mathematics Paper 2, I'm going to look specifically at question 7, which is it's on trigonometry, but specifically it is on trigonometric functions. Okay, now I know this section, it's one of those sections whereby students don't like trig functions. Okay, they say trigonometric functions are difficult, but today I want to show you an approach that you can use when you're answering questions based on trigonometric functions, because this is part of trigonometry. And as I said, trigonometry in the exam is going to contribute 50 plus or minus 3 marks, which is approximately a third of paper 2. As I always say, that it's very important that you master each and every aspect of trigonometry. Okay, trig functions. Now, what are the things that we have to take into consideration when dealing with these trigonometric functions? Okay, because this is quite an easy section if you understand your trig functions, how they behave, and what are the features of the trig functions. It becomes a very, very, very simple section to grasp. Okay, now when it comes to trigonometric functions, this is the map for trig functions. Let me write it here. This is the map for trig functions. Okay, or let me just write the key aspects that you have to take into consideration. First thing first, know your original or your parent function. I always refer to them as your parent function. Know your original or your parent functions. It's very important to know your parent functions or your original functions. What are those parent functions? You have a graph, of course. First of all, y is equals to sine x. This is the parent sine function. Okay, all the other functions are going to be derived from this original function here. They're going to come from this original function here. Okay, know how this one behaves so that you can be able to do it, to plot or sketch the other functions that they give you based on that one. Okay, now this one, let's say I'm only sketching it for x is an element from 0 degrees until 360 degrees. This one, it behaves like this. It's a wave. Okay, but because I'm restricting it only from 0 to 360, it's gonna be this way. Now this is a graph y is equals to sine x. Now it has a maximum at 1, it has a minimum at -1. Okay, and its period, the period of this graph, is 360 degrees. Okay, and how do you see the period? If here there is a number here, let's say you have y is equals to sine of kx. Now this k here is going to affect the period. That's very important that you know that the k here will affect the period. Okay, which means therefore the period, the equation that you use to get period, if there's a constant in front of the x, period is equals to 360 degrees divided by k. So you take the 360, you divide by the constant in front of the x, is going to give you what? The new period of the graph. Now this graph has got an amplitude of 1. Now amplitude of 1. Now what is the equation to get the amplitude? Now the amplitude, this is the amplitude. We are saying this amplitude equation, the amplitude, to get the amplitude, you say what? The maximum minus the minimum divided by 2. So that's the formula that you use to get what? The amplitude. Okay, so the max of this is 1 minus the minimum is -1 divided by 2. So 1 plus 1 divided by 2 is 1. So that means the amplitude is what? It's 1. Okay, that's very important that you know to get your amplitude. You must also be able to get things like your range, the range and the domain. The domain depends on this. The domain, they give it to you in most of the cases, because they tell you that this function is sketched within this domain. Okay, so that means you have to know your range. What is the range of the original, the mother or the parent sine graph? The range, it's y is an element, it ranges from -1 until 1. That is where the function ranges on the y-axis, from -1 until 1. That's where it behaves on the y-axis. But as soon as there are other shifts or other effects like transformations on this function, then your range will also be affected. That's very important. For example, if I say now the function is y is equals to 2 sine x, the range will be affected now. Okay, so you must take into consideration the smallest details and know your features. Or if I add a 2 now, I have changed my range also. Okay, the range has been affected. But changes in x, when I say sine 2x, y is equals to sine 2x and y is equals to sine x, this is a change in the what, in the period. It doesn't change anything about the y value. So there's no change in the y values, meaning that anything that affects the x does not change my range, which means if the change is affecting the period, that will not change what, where the function behaves on the y-axis. It's not going to affect where the function behaves on the y-axis. It is only going to affect the domain of the function, or affect what, it's only going to, if I say sine 2x, let me explain it properly. If I say sine 2x like this, if I say y is equals to sine 2x this way, what is this telling you? What is this 2 telling you? This 2 is telling you that, look, the original graph was y is equals to sine x. The original graph y is equals to sine x has got a period of 360. That means after every 360, it stops and then it starts. It's a one full cycle. After every 360, after 360, it starts another what? Another cycle until 720. Okay, that means every 360 is doing what? It's repeating itself after 360 degrees. Now the moment you put a 2 here, the period will now be 180 because it will be 360, you divide by the 2, which means now the function is no longer repeating itself after 360. Now it's repeating itself after every 180 degrees. It's completing a cycle, which means in a period or in a space of 360 degrees, you will have 2 functions. Okay, it's going to be this way, just going to make it do that. In a space of 360, this is at 180. Now in a space of 360 now, you will have what? You must have 2 full graphs of sine. When you have a 2 here, that's what it's telling you. It's giving you the number of graphs that you are supposed to have in that space of what? Of 360 now, because the period will no longer be 360, but it will be 180, meaning every 180 degrees is going to stop, repeat, and then another 180 to 360. It's a second cycle. Okay, like that, like that, like that, like that. Okay, so these are the small details that you have to know. Okay, also the cosine graph. The cosine graph, you have to know also the cosine graph. Okay, let me just, before I go to cosine graph, write the format of this equation, the trig functions. Okay, so the general form of this function, general form of the sine graph is going to be y is equals to a sine of k x plus p plus q. Okay, what does this mean? Let me explain each parameter so that you can see. You must spot on the equation. The a here is going to give you what? Is going to tell you the a tells you the what is the number here in front. It's going to tell you the what? The maximum of the function as well as the minimum most of the cases. If there is no q, if q is not there, if there is no shift here, if q is 0, then this here is going to tell you what? Is going to tell you that, okay, if let's say it's 3 here and there is no q, it's going to tell you that, okay, the function has a max of 3 and a min of minus 3. If q is 0, please take into consideration if q is 0. But if there is a q, then these values here will also shift depending on what q is. If q is 2, then that means here we'll also be adding 2. Okay, that's very important. It will depend on how high, depending on the q here, is the one that's going to shift your graph up and down. Okay, so the k here affects your period. It tells you the number of graphs you're going to have in a space of 360 degrees. Okay, and then the plus p here, this is a shift horizontal. It's a horizontal shift now. Okay, if you have x plus 30 degrees here, that means your graph is shifting 30 degrees where? To the left. If you have plus, you go to the left. If you have minus, you go to the right. Okay, you must know that. Okay, q just tells you the vertical shift of the graph. Okay, this is also very important. It affects your range. This affects the range. It affects the range of your function. Okay, it's going to affect your range from your mother function. Okay, now the cosine function also behaves the same way. Okay, but let me write it standard form. The cosine graph, it also behaves the same way with this. It behaves the same way. But the cosine graph, just that the shape is not the same as the sine graph, but the behavior is the same. It's similar. They have similar behavior. Okay, the one it's given as the general form is y is equals to a cosine of k x plus p plus q. Now the features are still the same. They mean the same thing. Just that the one for cos, the mother graph, it's y is equals to cosine x, and it looks like this. Okay, this is how it looks. Okay, but the features are the same. You have to know the features of those two functions, right? And then the last one that you need to know is the tan graph. Those are the only three graphs that you have to know: sine, cos, and tan. And then you just need to know what the shifting of those graphs and the transformations that they applied to them. Okay, and the transformations. After knowing the transformations, then you can then work on any question of trig functions. Just make sure you understand the basics of trig functions, because you cannot be able to answer trig functions if you don't know how the parent graphs looks like. Okay, then the tan graph, still it's y is equals to a tan of k x plus p plus q. Now this one, the period, it's 180. Okay, every 180 it repeats itself. Now it looks like this. Let me just do a rough sketch of this. Now this one, remember, it has got asymptotes. This one has got asymptotes at plus minus 90 at 90. If I'm only drawing it on this side, it's going to have an asymptote at 90 there. Okay, and it's going to look something like that. Okay, it's going to look that way. It approaches this asymptote, and the asymptote will be at 90. This is the graph y is equals to the tan of x. Okay, and then it's also going to go like this. Okay, also at 270 is going to have an asymptote at 270. Okay, at 90, at 270 is going to go this way. It intersects at 180 degrees. Okay, this is the basic form of what, of the tan function. Now the features are the same. K will affect your what, your period of the function. Okay, but remember the period of the original, it's not 360 but 108. P is the same thing, left or right. Q, up and down. Okay, interesting. Now let's look at this question and try to apply what we just said. Now, okay, try to see how we apply this. Now you also need to know how to interpret functions in general, because trig functions are related to what, they are functions themselves. Okay, they are functions, so you have to know how to interpret functions in general. All right, okay, let's see what we have here. Okay, here they say in the diagram we have got the graphs of f of x is equals to 2 cos x plus 1, as well as g of x is equals to sine 2x. Now can you see there's a 2 in front? That means the period is no longer 360 but 180. It has been affected. Okay, and they are drawn for the interval minus 180 to 8. The 180, they are giving you what, the domain. This is the domain. The domain is given. Okay, now let's see. These are the graphs. They sketch them for you, so likely you don't have to sketch them. The sketch is given to you, right? And the first question, they say write down the range. As I said, write down the range of f. Now the range of f, as I said, we're looking at the possible y values that this function can take. Okay, the y values of this function. Let's just see, where is this function defined on the y-axis. Okay, now on the y-axis, the values that this function is taking on the y-axis, look at the f of x. Now the original graph, as I said, y is equals to cosine x. It looks like this, and it has a range. Y is an element from minus 1 to 1, because its minimum is negative 1, its maximum is 1. But as soon as I put a 2 here, remember I said if this was not there, this is q. If q was 0, then it will just mean that this is stretched by a factor of what, for 2. That means the function is being stretched by a factor of 2, which means the maximum will be at what, will be at 2, the minimum will be at minus 2 if q was 0. But now we are adding 1. Okay, that means the range, let's just say for y is equals to, this is how we get the range. For y is equals to 2 cos x, when here is plus 0, the range is y is an element from minus 2 to 2. But now I add 1, that means from where it is, I shift it 1 unit upward, which means now I add 1 to every value. Okay, to every value here that's in the bracket, I add 1, which means it's going to be y is an element negative 2 plus 1, 2 plus 1, because I'm then shifting it up 2 units. Okay, which means it's going to be y is an element from -1 to 3, and that is your range. Okay, that's how you get your range. Remember I said q will affect the range. Q is going to affect your range. If q is there, is present, your range will be affected. But if it's 0, then this number here is going to give you an indication of the max as well as the mean of the function, meaning it's going to tell you the range. Okay, so the first question, the range is going to be y is an element from -1 until 3. Okay, and both of them are included because the function at -1 and 3 is defined there, so it exists there. Okay, easy 1 mark. And they say write down the period of g. Where is g? Now g, the equation you can see, g is the sine graph, and I said the moment you have a number here, that number affects the what? The period, which means the new period of g is going to be 360, because the period of a sine function, the normal y is equals to sine x is 360. So we divide by k, which k in this case is 2. So 360 divided by 2 is 108. So that is the new period. Easy 1 mark again. Okay, so write down the period of g. Period is 180 degrees. Another 1 mark. Okay, now they say for which values of x, what are the values of x in this interval, in the interval where the functions are sketched, is the function increasing? Where is this function increasing? Okay, now where is the function f increasing? Now f, remember, is the cosine function. Where is this function increasing, the cosine function increasing? let's see where it's increasing. Okay, right. Now f is my cos graph, the cos, yes. So can you see that here, starting from -180, sorry about that, starting from -180, we remember we interpret from left to right, never interpret from right to left. No, we go from left to right in that direction. Now can you see that as I move from left to right, I'm going up? That means the y values are increasing, 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 they're increasing, they're increasing, they're increasing, they're increasing, they're increasing, until we get to this point here where the y values are not increasing nor decreasing. So they are not increasing nor decreasing. And then as soon as we move that way, you see that the y values, they start decreasing. That means we are going down, 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 and then we just decrease like that. So where is the y? Why are the y values increasing? Let me remove this. Where are they increasing? They are increasing from -180. These are the values of x, from -180 until we reach, what is x here? It's 0. X on the y-axis is 0. Okay, it is 0. But let's see. Okay, yeah, so I'm going to say here x must be an element from -180 degrees. Okay, look, because -180, it is included there. Okay, and one thing, if they say where is this function increasing and strictly increasing, if they just say increasing, you can include, because they did in the exam. If you look at the memos, if they just use the word increasing, even if you include or you don't include, you will be marked correct. But if they specifically say for which values of x is the function strictly increasing, if they say strictly increasing, you cannot include, because they said strictly, you cannot include. They say reason why here you can include, here you cannot include, here you cannot include here. Okay, if they say strictly increasing, you can't include. But in this case, they just said what? Increasing, you can include, and they're including what? -180 until what? 0 degrees. Okay, you can give your answer like that. Okay, you can include in this case, because they say what are the values in this interval? Is this increasing and is increasing? Here from -180, we're saying it's increasing, but it's going up, it's going up, it's going up until we reach what? 0. So 0, I'm also including it. Okay, but you can give your answer this way: x is an element from -180 degrees until 0 degrees, because at -180 you can view it as -180. You don't really know. I think you can include here, but at 0 you cannot include. Okay, you can include this one here. but you cannot include at 0, because at 0 you view it as if it's not increasing, so it's not increasing, so you're saying we cannot include it because at 0 it is stationary. It's at the turning point, it's at the tip of the function, and then it goes down. So here it's turning there at this point, so you cannot include it. Okay, but because they just used the word increasing, they didn't say anything about strictly increasing. Okay, and at minus 180, do we know what the function is doing at minus 180? Let's see. At minus 180 is where it's turning also. Okay, I think this is where it was supposed to do this, something like that. It was supposed to it was supposed to go up like this. Okay, it was supposed to turn and then do something that regards. Okay, so that means here it's also where it's turning, but you can include here. Okay, you can give your answer this way. You can give your answer this way. You can give your answer that way and say, okay, because at those points it's not increasing, because those are generally they are generally the what? They are generally the turning points. That way, and then the turning point, you can think of it as it doesn't increase. But even if you gave your answer this way, you will still be marked correct, because they didn't use the word strictly increasing. If they use strictly increasing, be careful there. Okay, strictly increasing, be careful there. Okay, alright. Now let's see 7.4. I hope we are clear about this one. Okay, let's check 7.4. Okay, 7.4, they say use the graphs, don't solve any equations. Okay, use the graphs to determine the values of x in the interval from minus 180 to 184, which this is true. G of x, when we multiply it with the first derivative of f of x, the first derivative of f must be less than 0. Now, the reason why they are saying use the graphs, look at this. G of x, if you try to use algebra, this is where you are going to face issues here. You're going to have a mathematical breakdown now here, because G of x, you see the G of x, okay, it's sine 2x. We are fine with that. We can just see, let's say sine 2x. I want to show you what's going to happen. Times, now f prime of x, now you have to get the what? The first derivative of this. Now let's look at what f of x is. Now look at what f of x is. F of x is 2 cos x plus 1. Now, in order to get the derivative of this in your curriculum in metric, to get the derivative of this, it's impossible for you to be able to differentiate this in metric. Okay, unless if you are doing AP Maths or first year calculus, that's when you can be able to say, okay, this is a trigonometric derivative. That means the first derivative is going to be 2, then this one I think is minus sine x. The derivative of constant is 0. Okay, because when you differentiate sine, you get cos, you get negative sine. It's going to be negative 2 sine x. But in your curriculum, you don't know this. This is not something that you learn or something that you know in metric. So you will never be able to just substitute it here and try to solve the equation. Okay, it's going to be impossible for you to find the first derivative. That's why they are saying what? Use the graph. So you have to understand what is the first derivative doing to you. It's giving you what? The gradient at a point. Okay, this is giving you the gradient. So for us to multiply two quantities in mathematics and then we get a product that is less than 0, it means we must have a positive times a negative, or a negative times a positive. That's what we have, which means we are looking for where g of x is positive. And where is g positive? Above the x-axis. And at the same time, the derivative is less than 0, which means the function is decreasing. So we're looking for where g is above and f is decreasing at the same time. Where is g above the x-axis and f decreasing at the same time? Let's check. Okay, g above the x-axis, g is this graph above the x-axis, and we want where f is decreasing. So g is above here, it's above until here. But when you look at that interval, this one is increasing. Okay, so we cannot fit there. Okay, and another way where this is positive, it's above, and then here it stops. Okay, so that's when we have an issue, because this one here, can you see? from zero, from that zero here, if we look here from that zero, and then we go from that zero until here, from that zero until here, until here, until here, when x is what's x here is d is my sine graph. So here x here, because we know the sine is sine to x, that means this one is now at let's see, because my graph, the normal one is this way, okay, the normal graph is this way, and then here it's 91, then it's 180, that means here it's 90, x here is 90 here, okay, x will be 90 degrees there. So from zero here, from zero until when x is 90 degrees here, from zero to this point here, this is also from zero, this is positive, this one is positive, it's above, it's positive here, it's positive, 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 this is decreasing. So within this domain, let's shade. So I'm going to shade here. This is where the condition is both satisfied, so I'm going to shade here. I'm going to shade here, everything here, I'm going to shade here, everything here, everything here, the condition is going to be satisfied, everything that is here, everything that is here. Can you see this region that I'm shading in blue? Everything that is here, everything that is there. Can you see that this one, it's going down, it's decreasing, this one is decreasing, this one, it's what, it's above the x-axis, is positive. So from 0 to what, to 90 degrees. Okay, so for x, it's an element from 0 to 90 degrees, and you cannot include, because at 90 degrees, look, at 90 degrees, this is 0. At 90 degrees, g is 0. So if g is 0, that means the product will be 0, but there we didn't include 0, so don't include. Okay, do not include. And also at 0 degrees, here you have a, don't include 0 degrees, because they didn't include there. Okay, they don't include there. Okay, because why? We are saying that the product must just be less than 0. We don't want it to be 0. Okay, and at 0 degrees, again, this is 0. So if you include 0 there, you'll have a problem, because at 0 degrees, g is also 0. So that means the product will be 0. So don't include. Here you cannot include. It's an exception. Don't include. Okay, let's see. Is there a scenario where g is below and this is increasing? Let's see. Is there a scenario where g is below and the other one is increasing? Let's see. G is below and the other one is increasing. Yes, let's see here. Here, this is below. It is below here. It is below. And this region here, this one, it's going. Sorry about that. Okay, so we're saying this one, it's decreasing in this interval. Okay, it's going down, it's going down, it's going down, it's going down, it's going down. It's below, in fact, it's below the x-axis here. It's below, so that means that it's negative. This one, it's doing what? It's increasing. It's increasing. It's increasing. It's increasing up to there. Okay. Okay. So that means this one, it's increasing here. It's going up. It's going up. It's going up. It's going up until we reach this point here. Okay. It's increasing here from here. When this one is below. So from minus, this one is going to be minus 90, I think it's going to be minus 9. So from minus 90 until 0 here. Okay, so the shading here will occur here. The shading will be here. This is where the shading will be. We shade in this region, so we can shade there, here. This is where my solution, like this, my solution region. Okay, so that's when we have another solution. So from minus 90 until 0. Okay, so we can say, oh, x is an element from minus 90 until 0 degrees. Don't include, because at minus 90 this is 0, At 0 again is 0, so don't include because the product will be 0 if you include. Okay, so we can write this solution in interval notation. We can say therefore x must be an element go from negative 90 degrees until 0 degrees, union from 0 degrees until positive 90 degrees. This is how you can write your solution set. Okay, your solution in interval notation. Okay, you move from negative 90 to 0, from 0 to 90. Okay, that is when this condition is going to be satisfied here. Okay, and 7.4.2 they say where is the use the graph to determine the values of x in that interval for which cos x is less than or equal to negative 1 over 2. Now don't solve, don't get our reference angle and try to know. This is how what we are going to do. We are going to see where is, first of all, let's find out where is this cos graph equal to negative 1 over 2. Where is cos equal to negative 1 over 2 in that interval? Where is it negative 1 over 2? Now this is what I'm going to do. Why is it the cosine graph cos x? Use the graph to cos x. But here, can you see that here we have got 2 cos x plus 1, but here they are saying what? Cos x is less than negative 1 over 2. Now this is what you do. Okay, you are going to have to use this graph. This is what we're going to do. They give us cos x less or equals to negative 1 over 2, but the one that we are given here, the one that we have here, it's what? It's 2 cos x plus 1. So we must form that graph here. So first of all, I'm going to multiply both sides by 2. Okay, that's what I'm going to do. I'm going to multiply both sides by 2. So I'm going to multiply this side by 2. I'm going to multiply this side by 2. You can do that in an inequality. It's a numeral, it's positive, so you don't change the sign of the inequality. So therefore, that means I get 2 cos x less than or equal to negative 1, because this 2 will divide there. But here it's 2 cos x. The one that I have here, it's 2 cos x plus 1, which is the one that I can use to interpret. So I can add 1 on both sides of the equation. Okay, I can add 1 on both sides of the equation. That means I get 2 cos x plus 1 less than or equals to negative 1 plus 1, which therefore means that I get that 2 cos x plus 1 less or equals to 0. And this here, what is 2 cos x plus 1? This is my what's that function? It's f of x. So in actual fact, they're saying why is f of x less than or equals to 0? This is the question mark now that we have to answer. Okay, so can you see, you have to use what we have, form the graph that they want. Okay, so one where the graph of f is below the x-axis. Where is f? F is the cosine. Where is it? Below the x-axis in that interval. Okay, in the interval from minus 180 to 180. Let me erase here so that I can then see. Okay, so it's going to be below here. It's below here. Can you see that here is below? It's below here. It's below here. From where? What is the value of x there? What is the value of x here? The value of x here, you have to get what is the value here of x. It's below. Also here, it's below here. You must also get what is the value of x there. If you get those two values of x, then you can maneuver and work out and work from there. Okay, so how are we going to get those values of x? Let's see what we have. Okay, so this cosine function, it was not affected on the, was it affected on the x-axis? No, because the 2 affected it on the, y-axis, and the plus 1 just shift it upwards. Okay, so let's see. The normal cos graph is going to do this. This is the normal cos graph. It's going to go that way and then this way. So here it cuts at positive 90, and then there it was supposed to cut at minus 90. Okay, but the problem is now, let's see, the problem is let's see. Okay, so you can do it this way. You can go on the side, you can go to your side next, on the side where you do your workings, and then you just take this equation, 2 cos x plus 1 is equals to 0, and then you want to try to see what should be x here. Okay, what should be x there? So you can then say cos x is equals to negative 1 over 2, and then to get x, you can just say it's the cosine of let's see if I say negative 1 over 2 there. Okay, let's do this, and then let's see what angle we are going to get, because it's telling us where the function is 0. Okay, let's see what we get. Let's see what we have. So I'm going to say shift cos. I'm going to say shift cos, and then I put negative 1 over 2. Okay, it's going to tell me that here it's 120. This is 120 here. Okay, it's giving me the fact that this should be 120. This on this side should be negative 120. You can test it, should be minus 120. Okay, that means for x values from minus 180 to minus 120 for this solution here, I'm going to write a degree. So it's going to be x should be an element from minus 180, and it's included because at minus 180 you're going to include here. Okay, let me first include minus 120, because why am I including minus 120? Look, at minus 120 here, at minus 120 it's 0, so the product will automatically, this will be less than 0. Okay, it will be less than 0 there. Okay, and at minus 180 still is less than 0, so I'm going to include here because they included. So I'm going to, here it's minus 180 because that's where the function starts, it's the limitation of the function. Then I'm going to say union from where, because this is from 120 go to 180, that's why it's below 120 to 180. So I'm going to say 120 to 180. I'm going to include, because here it is 0, but still at 180 it's below, so the condition is satisfied. So this is my solution set for this one. Okay, I hope I didn't make any mistake. If I make a mistake, you can comment on the comment section if there's a mistake, but this is what I do to get this solution here. Okay, and yeah, that's where it's below the x-axis, because f(x) less than or equal to 0 just means where is the function below the x-axis. Okay, below the x-axis. Okay, and the last one, 7.5, they say here graph G is shifted 45 degrees to the right to obtain a new graph H. Okay, this was the simplest trig function question, because they say graph G. Where is graph G? They say graph G, and I told you about shifting to the right, horizontal shift. Graph G is shifted 45 degrees to the right. We're shifting it 45 degrees to the right to obtain a new graph H. To get a new graph, that's its name is H. Let's determine the equation of H in simplest form. So let's get the equation of g of x first of all. Where is g of x? G of x is sine 2x. Okay, g of x is sine 2x. Now when we shift to the right, remember I gave you the standard form that is going to be y is equals to a sine k x plus p plus q. Now the shifting horizontally is going to take place inside this bracket here. That's where the shifting horizontally is going to take place. So what am I going to do? I'm going to say, therefore, that means that g of x is going to be or h of x rather, because they say it's obtaining new graph H. So h of x will be sine of 2, and then I have what? The x now in this case is going to be x minus 40. Is it to the right? Yes. When it's to the right, you shift it. When it's to the right, you shift it. You say minus, you don't say plus if to the right, you say minus. Okay, that's what we have. So that's what we are going to do. Okay, you're going to say sine 2, and then in the brackets where you see x, because you can actually view this transformation like this. This transformation you can view it as h of x. H of x is actually g of x minus 45 degrees. You can view this transformation like this. H of x is g of x minus 45 degrees. Therefore, you can then simplify this and say h of x is equals to the sine. You can multiply inside the brackets here. You have 2x minus 90 degrees. Okay, 2x, 2 times x minus 90 degrees was 2 is a number, it can distribute there. Now this can be simplified and say this is the same as sine negative 90 plus 2x. And this, ladies and gentlemen, it's, you go back to your reduction diagram. Okay, your reduction minus 90 means you start here and then you move 90 degrees clockwise, you'll be here, and then plus you move minus 90, you'll be here. Okay, at this point, and then you plus means you move now in an anti-clockwise direction. You move a smaller distance in an anti-clockwise direction, you end up in the fourth quad. I explained how to do reduction in one of my videos. Okay, your starting point is always at 0, and then if it's minus 90, you move 90 clockwise. That means you're going to start here, you move this in the space of 90 degrees clockwise, you're at this point. Plus means move anti-clockwise. A positive angle is anti-clockwise. So you're going to move a smaller distance in an anti-clockwise direction. You end up in the fourth quadrant where sine itself is negative, so you're going to put minus there. But because sine it's a we have a 90, it's going to change to be cos 2x. Okay, so this is h of x. It's minus cos 2x because they said do it in simplest. So that means the new equation of h of x is negative cos 2x. Now, I know trig functions, most of you view them as they are difficult and stuff, but if you understand your basics and how to interpret them, you can actually make it in trigonometric functions. I hope you enjoyed the video and you learned something from this video. Please comment on the comment section if there's something that I made in the video, or if there's something that you want me to explain clearly in the next video. Thank you very much.